Hi and welcome to the tutorial Materialized Views with Azure Cosmos DB. Pre-compute the answer before anyone asks the question. This tutorial builds a real-time materialized view of customer order summaries, kept fresh by change feed, read at single-digit RU cost. In the table below, the left panel recomputes an answer from raw facts every time it is asked. The right panel is that answer already cast into its own document, kept in sync in background. That's the whole idea of this tutorial. What you will build is an order container as the system of record, write model. Each order carries a customer, a date, server computed total, and an embedded list of line items. Also, we will have a customer order summaries container as the materialized view for our read model. Totals, loyalty tier, for example, it can have a favorite product and caprice and order history, or any other aggregation that you can think of, you can include in this aggregated view. An Azure function isolated worker with .NET 10 that maintains the view from the change feed in real time. A minimal API exposing both the fast materialized read and a slow live aggregation endpoint, plus the request HTTP file that covering all the three endpoints that we are going to have in this demo. So let's see what is a materialized view. A materialized view is a pre-computed denormalized results that is stored as its own physical document rather than recalculating on demand. It answers one specific question extremely well at the cost of being a second copy of drive data that someone has to keep in sync. Contrast this with a regular database view in relational world, which is just a saved query. It still returns against live tables every time it is read. The materialized view actually persists the output. In Cosmos DB, there is no built-in materialized view object like some relational engines. You build the pattern yourself using two containers and a synchronization mechanism. That mechanism is almost always the change feed. Source container, ledger of facts, what happened, materialized view container, a pre-baked answer to a specific question, what's true right now. The change feed is the pipeline that keeps the second one honest as the first one has changed. It is not the same as caching. A cache is typically a transient expiring key value copy sitting in front of a database. A materialized view is a first class durable container in Cosmos DB. It has its own partition strategy, its own indexing policy, its own RU budget, and it is queryable with full SQL API power. It doesn't expire, it is continuously maintained. Why you should consider using materialized views. The short version, reads become cheap and predictable at the cost of a small amount of right side complexity and eventual consistency on the drive data. In an event-driven system, that's usually a trade worth making. In the table below, we have our concerns column and also two columns that's how this behaves in query time aggregation and materialized view. RU cost per read is scales with resource data volume in the aggregation, and also in the material view it is flat single point read. This is the benefits. Latency grows as history grows with aggregation. Constant low millisecond in the materialized view, also a good benefit. Cross-partition fan out, often required with the aggregation, but with materialized view avoided by design. Very good basically point. Freshness, always exact computed now but in the materialized view, it is eventually consistent, but it is near real time. Write side cost. Basically, you don't have, because you just write it to the orders containers, for example, in our example, but with the materialized view, for every order, you need to basically write it, and you should rely on the relay function as the source changes. Operational surface for one container, but in materialized views, you need to keep two containers and basically sync them. So these are the pros and cons of having a materialized view. The pattern earns its keep when the same aggregate, a total, a rollup, a top n, is read far more often than the underlying facts changed. Read-write ratio matters. Computing the answer requires a scanning across partitions or a large history, which is exactly what Cosmos DB's partitioning model wants you to avoid. You want to shape data specifically for a UI or downstream consumer without pulling the write model. This is the read side of CQRS. Different consumers need different shapes of the same underlying events. You can maintain several views of one change feed. Where this is overkill. If the raw query is already a cheap same partition point read or a small range query, don't add a second container just for the sake of it. Materialized views trade write side complexity for read side speed. Only take that trade when the read pattern actually demands it. Here we have our architecture, our demo that we are going to go through together, that we have two containers and one relay. The order container is partitioned by customer ID so that a customer's full order history lives on one logical partition. Cheap to aggregate if you ever need to rebuild the view from scratch. The materialized view container shares the same partition key, so the view read is always a single partition point read. Our minimal API never touches the order container for the common case read, if only reads the summary. Writes to order are only things that ever mutates the source. Everything downstream reacts to them. Real-time materialized views. Real-time here means near real-time. Cosmos DB's change feed is persistent. Ordered log of inserts and updates per partition key range. The change feed processor hosted by Azure Functions Cosmos DB trigger pulls for new changes continuously and delivers them in a small batches, typically within a second or two of the write. How the loop works. First, an order is written to the orders container. A new document or an update lands via the minimal API's create item async call using customer's ID as the partition key. Second, change feed picks it up. The function Cosmos DB trigger bound to the order container with an identity-based connection or connection string receives the changed documents as the next batch. Third, the function recomputes the affected summary. It groups the incoming batch by customer ID, then for each affected customer runs a same partition aggregation query against orders, cheap same partition bounded by that customer's history, and observes the result into the customer order summaries. Fourth, readers see the update. The next point read against the summary container reflects the new total, typically within 1 or 2 seconds of the original write. So almost near real time. Here I am in JetBrains Rider, and I'm going to show you the solution which has one class library and two other executing project. One of them is the minimal API and the other one is the Azure Function Trigger for the Cosmos DB. Let's first go through the shared project. Here we have two models. One of them is the order that a customer is going to make. In our case, we kept it really simple. We will have an ID, which is a GUID, and the date of the order, the customer ID, which is the partition key, the total price of this order, and also this order has line items. These line items are the product ID, product name, price, and the quantity that the customer bought. Next is customer order summary. This is the materialized view content that we are going to build in our change feed function. And for this also we have ID and customer ID. The ID and customer ID in this case will be the same value. It will be the customer ID because with that we are going to use our single point read. We will calculate the total orders. What is the total spent money? How many in this for the total orders? It means that how many orders a customer created in the system. Total spent by the money. This is also a calculated value royalty tier, which I'm going to describe it a little bit later. And also we have a list of orders with a different shape, and also we have updated at field. So in the order summary line, here we have our order ID, the order date, how many items was inside that order, and the total price of that order. So for example, imagine that you have a UI and you want to show this order list to a customer. Basically you can gather this information from the view and show it, and as soon as a customer wants to know more details about each order, he or she can click, and then you can load that specific order with that. Next, I'm going to show you the API project. Here we have one and only program file, and in the program file, if we go to the top, we have our Cosmos endpoint. You can use basically a simple connection string for this demo, but in the real time, maybe you should consider the managed identities. Here we have also our database name and order container name coming from the configuration. And also we have our summaries container name. Here we have also a get request because we want to, at the end of the demo, compare that how many RUs is reported by querying these aggregates from the database. So then we basically register our Cosmos client to the dependency injection, so we can inject it to our HTTP endpoints. We have first a post request. This post request basically gets an order object and inserts it to the orders collection. We have here our fast point read against the materialized view, which basically should use one RUs. This function is a get, so it just returns that one. And also we have here our slow on purpose recompute for showing you if without materialized view, if you want to have some calculation or aggregation, how the RUs can increase and grow, and eventually in a system that is used by thousands or millions of users, how it can increase your costs. So in this example, we run a query which basically gathers the total orders, the total spend, and the last order date. Basically, this is not a really huge aggregation, but in the real world, it can be much more than and much more complex than this. In this project also, we have an HTTP request file. So we are going to make use of this file for sending our example request. I will pin the tab, so we will use it later on. I open the functions project. We go to our program class. Here, very simple, we register the Cosmos client to the dependency injection. We expect the Cosmos connection from the configuration. And if we open order summary projector file, go to the top, and this Azure function trigger basically needs some values like the database name, order container name, orders and summaries container name, which is our materialized view. And we inject a Cosmos client here. Here is the trigger. It needs the database name, container name, which is the order container. We have also our connection string to the Cosmos DB. This is the lease container that Azure function needs for the checkpoints. And also here we just mentioned that don't create the lease container. And also we will get a list of orders when this function gets triggered. So based on that, here we check if there is nothing in it, we just return from the basically function. If there are, then we basically create our container, our summaries container, and we basically go through the changed orders, which is coming to this parameter for us. And based on that, we will build our summary, I mean the materialized view, and then we will observe that document to the database, to the materialized view container. So let's see what this method does. Here, first of all, we create an order summary object, which is our material view object, and we assign the customer ID and also, I mean the customer ID for ID and customer ID, because one of the customer ID here is also the partition key and the ID is the same. And we are going to download if there are any existing materialized view for this customer. If yes, then we will download it. If not, then we have one, so we can basically pre-calculate everything here. For example, the total order will be +1. The total spend we can calculate here, the updated date time, and also here we can count our loyalty tier by this function. How? For example, if the amount of the orders, total orders of a customer goes more than 500, then the customer is silver, 2000 is gold, and 5000 is platinum. And by default, it is bronze. So basically, you got the idea. This is very simple, but you can extend this pattern to your need and what your business requirements satisfies. I'm going to close all the tabs here and open this up to reduce the noise, and I'm going to run the project, and we are going to see the results in the Azure portal. Let me run the API project first, and then in the meantime our function. It shows that both our applications are up and running. So I'm going to create an order. But before that, let me show you what we have in Azure. So I am logged in already here, and I created a Cosmos DB account for saving time. And in the Cosmos DB, we have our retailed DB database, and also we have our customer order summaries materialized view the lease container, which is used by the checkpoints of Azure function, and the orders. So I'm going to open the orders, and currently we don't have anything here yet. And also let me open the order summary here side by side, and I'm going to now fire the request. So let's go back to Rider and create the first order. It was successful, and we can double check that if we come here in the orders container. We got our first document with 2 items on it, and also we should have our document in the view. As you can see, we have also our view created with the ID and customer ID, the same value. The total order is 1, the total spend, the loyalty tier is bronze, and the order, basically we had 1 order, and this is the summary of that order, the ID, date, item count, and the total price of that order. Let's go back to Rider and fire the second order. I quickly go back to portal, and we should have our second order here, and also we should see that something has changed in this document. As we have our second order listed here, we have still the loyalty tier is bronze, but the total spend money has changed, and also our total order. I'm going to fire the third create order maybe another time, and in this case if we go back to our orders, we should have 4 orders already created, and also some changes here. As you can see, we have 4 orders already, and our loyalty tier changed to silver, and the total order is 4. Now we come to the interesting and important part. If now I go back to Rider and we go to the fast read materialized customer summary. So if I fire this request, as you can see, we were able to download our materialized view document really quick with the information as we saw in the portal, and this request charge was only 1 single unit, and that's the whole point of it. And if we want to create that aggregate, basically I showed you in the code, which was consistent of 3 properties in it. Let's see how the system behaves. So for that, as you can see, we got 3.69 RUs spent for just having these 3 values as the aggregate. And every time you have to basically pay these RUs even more when you run the query. So this brings us to the end of the video. I'm going to push the source code to the GitHub and provide the link in the description. Feel free to drop your suggestions or questions in the comment section, and I'm going to answer them as quick as possible. By the way, if you are interested about implementing outbox pattern in Cosmos DB or implementing RAG with Azure Foundry Cosmos DB, definitely check out these 2 videos which are appearing on the screen. Hopefully see you in the next video. Until then, take care. Bye.